I've had a few questions about the exam study packet, chapter 6, number 4. Let's think about that one. This one asks about the labor discipline model. And remember, that model studies the effort level as a function of the wage rate on the part of workers, and then the cost minimization on the part of employers. So the way that model works is, on the y-axis, we have worker effort, and then on the x-axis, we have the wage rate, dollars per hour. And then workers have a best response function. Just to show up at the job, there's some reservation wage rate. And then as the wages rise, the worker's effort level rises, but at a decreasing rate. That's by assumption. So let's just mimic the example in the book. The firm, I haven't done a very good job. I wasn't going to hit a tangent. See, the firm minimizes minimizes its costs rather, by paying as low a price as it can to get the effort it needs. And so the isocost functions, remember, are rays from the origin that correspond to the effort per dollar that the firm has to spend. And rotating to the right, there's the dollar amount spent per effort unit is increasing. Remember that the dollar is in the denominator, so if that's increasing, the ratio is getting smaller. And then to the left, costs for the employer of securing an earnest effort from workers are falling. So anyway, the least cost way to get the work desired is where the isocost line is tangent to the worker response function. So the firm's objective here is to minimize costs subject to this constraint posed by the worker's willingness to put out effort. And we could imagine any initial equilibrium. I think a lot of the examples in the text just suppose that tangency occurs at some wage rate W naught, and I think Maria's effort level was 0.6 or 0.5, something. It doesn't matter really what it is. So then these events ask us, well, what's going to happen in this context, or is anything going to happen in this context? So the government decides to increase child care subsidies for working parents, but not for those unemployed. Assume Maria has a child and is eligible for the subsidy. Well, now the benefits from working, quite apart from the wages, go up, and that means that Maria is going to value her chance to work more. It's somewhat quite akin to the increase in employment rent we studied in the previous problem. So what's going to happen is that this change would shift Maria's best response function to the left. She's willing to put out more effort at any given wage rate, and so that's the way this is going to change it. And of course, we would then see, some new tangency. It could be, I could draw it in a number of ways depending on what I did to the slope, but suffice it to say that this would enable employers to pay a lower wage to get the effort to minimize the cost of getting the effort that they want. All right, and then so this next one's the tricky one. The demand for the firm's output rises as celebrities endorse the good. Well, that means the firm's revenues are going up, right? Price, quantity go up. We'll do some Chapter 7 problems to show exactly how that works. But a profit-maximizing firm, profits are total revenue minus total costs. So even if revenues are rising, the firm's still going to want to minimize its costs. So the reason why this is a tricky one is that this doesn't change anything. This is a no change event. So if you look at I didn't leave myself enough room. If you look at the wording, would any of the following affect Maria's best response curve or the firm's ISOCOST lines for effort? If so, explain how. And so in this case, the answer is no, no change. And then finally, improved technology makes Maria's job easier. Well, if her job's easier, then you don't need to pay her quite the wages that you did before to get her to come to work. So this would be another change that shifts the reaction function to the left.